Hello. So let's pick up where we left off yesterday. So yesterday we talked about the difference between an element and a compound. So tonight in our flip assignment, we're going to go a little bit further and we are going to talk about the difference between organic and inorganic. To understand these, you had to understand chemical formulas. So let's talk about a chemical equation. Yesterday, you learned that a chemical formula, like 2H2, tells us two things: the elements involved and the number of atoms of each element. So I want you to look at this entire thing. This whole thing is called a chemical equation. A chemical equation is made up of chemical formulas. So if I was to read this chemical equation to you, it would sound like 2H2 plus O2 yields 2H2O. Now, how many chemical formulas do you see in this chemical equation? There are three. 2H2 is a chemical formula. O2 is a chemical formula. The arrow always in chemistry stands for yields, which means to make one chemical formula of 2H2O. This is a chemical reaction. So the way that we write chemical reactions that occur naturally in our world on paper is to write them in a chemical equation. So kind of like math, when you write an equation, however, we do not use an equal sign, we use an arrow, which means yields. So there are two different parts on a chemical equation. There is the left side, which we call the reactants. These are what you are mixing together. These are what are going in to the equation or into your chemical reaction. So for example, we have hydrogen reacting with oxygen. That's it. The other part of a chemical equation on the right-hand side is called the product. Now, it's called the product because, like it sounds, this is what you make. So when you take hydrogen and combine it to oxygen, you make H2O, which is water. So water is formed by a chemical equation of hydrogen and oxygen. Reactants always make our products. Reactants on the left, products on the right. So two hydrogen molecules combine with one oxygen molecule to yield two water molecules. These large numbers in the front are new to you. These are called coefficients. Now again, that's not that important until 8th grade, but I just wanted to go ahead and give you the proper terminology. So these large numbers are the coefficients, which tell us how many molecules we have in our equations. And again, the small numbers, which we called subscripts, tell us the what? The atoms. And then the chemical formula, which are our letters, tell us the elements involved. So look at this picture. This is a visual representation of that chemical equation. Notice that I have two molecules, okay? One molecule here, one molecule here. So I have two hydrogen molecules. Notice my two for my coefficient. In each molecule is made up of two, one circle here and one circle here, hydrogen atoms. So how many total hydrogen atoms do I have going into my chemical equation? Well, the answer is simple. Count the circles. 1, 2, 3, 4. How do you think you get 4 from going up here and looking at the chemical equation? If you have a 2 for a coefficient and a 2 for a subscript, how do you think you come up with that? Multiply. So 2 times 2 is 4. So now let's look, Now let's look at the other reactant, oxygen. Now notice, do you see a large number in the front? Do you see a coefficient? No, you don't. Just like the rule of thumb with the subscript, if we do not see a number, we always assume it to be a 1. And notice we only have one molecule of oxygen. This one molecule of oxygen is made up of how many oxygen atoms? 2. So all these atoms, and if you'll notice you have 1, 2, 3, 4, 5, 6 total atoms going into this equation, what do you make? Over here on our right are our products. We have 2 molecules of water. So what happens is that they break their existing bonds, rearrange, and make new bonds to make something new. But notice, did the number of atoms change? We said we had 4 hydrogen go in. Do we have 4 hydrogen come out? And we had 2 oxygen go in. Did 2 oxygen come out? So atoms cannot change what they are. They can only change their arrangement. It would be like in class if I had everybody stand up, mix up groups, and sit down at new tables. Would you change who you are? Would you no longer be yourself? Of course not. You're always going to be who you are. But the combination of your table is different. That's what happens in a chemical equation and in a chemical reaction. So let's talk about organic compounds. Now, in today's society, when we hear the word organic, we think something completely different. We're like, oh, it doesn't have pesticides, it's good for you, it's healthy. Well, in science, organic means a little bit something different. Organic is any compound that contains the element carbon with a hydrogen bond. So this is so important. If you are looking at a chemical formula and it has a carbon in it, which is a C, and it has a hydrogen in it, which is an H, is it organic? Yes, it's that simple. When looking at a chemical formula, if it has a carbon and a hydrogen in it, it is considered an organic compound. All living things are organic compounds. You are an organic compound. So let me ask you this. Do you have carbon and hydrogen in your body? You must if you are organic. Common organic compounds. So what do they all have in common? Let's look at the very first one and look at methane gas. All right. This is what, let's be honest, cows fart. Okay. Very stinky stuff. Carbon's chemical formula is CH4. 1 carbon bonded with 4 hydrogen atoms. So is this considered organic? Does it have carbon and hydrogen? It does. It's organic. Now, if you look at this formaldehyde, which is what we use to preserve, and especially when we're dissecting or embalming people, it is CH2O. Does it have CH? Just always look for the CH. CH. If you see it in a chemical formula, it is organic. Ethanol, sulfuric acid, and histamine. Okay, notice that all of them have a carbon, all of them have a hydrogen, so therefore they are all organic. Elements often found in organic compounds. They are also included in other elements such as sulfur, phosphorus, oxygen, nitrogen, calcium, and iron. However, they do not have to have all of these other elements to be considered organic, but most of the time you will see these elements accompanying in the chemical formula. But remember, as long as they have a C and an H, as long as you have your CH, it is organic. But let's add a little bit to it. Sulfur, phosphorus, oxygen, nitrogen, carbon, hydrogen, calcium, and iron. If you would read the red letters as it goes down, it spells Sponge Cafe. I want you to write that down. You always want to eat at the Sponge Cafe. These are all organic elements. However, what's the most important part? When you write Sponge Cafe, I want you to put a box around the C and the H, because that is truly what determines if if a molecule is organic. So let's talk about inorganic compounds. If you have organic, then you have to have inorganic. In Latin, the prefix "in" means not, lacking, or without. So what do you think an inorganic compound is going to look like? Compounds that do not contain carbon and hydrogen. It is that simple. So when you're looking at a chemical formula, if you do not see a carbon and a hydrogen together, it is inorganic. If you do see one, it's organic. Is carbon dioxide organic or inorganic? So I want you to write that down. Tell me if you think it's organic or inorganic, and then I need you to tell me why. Notice the chemical formula is CO2. Now let's go a little bit further. Many of you have probably heard of carbohydrates, right? In the dieting world, it's a big thing. We call them carbs. Carbohydrates are compounds that use carbon, oxygen, and hydrogen in our body and break them down. Now, when you hear the word carbs, you probably automatically think of the potato, right? Starches. You think of pasta, potato, bread, these are all our carbs, and carbs are bad for you. Well, everybody has to have carbs to sustain life. Just too much carbs is where you get in trouble. Starches are carbohydrates, but sugar and glucose are also carbohydrates. A lot of people don't tend to think of sugar as being a carbohydrate, but it does contain carbon, oxygen, and hydrogen in its chemical formula, just like glucose. So therefore, it is a carbohydrate. Now, lipids. Lipids are things that we find in our fats and in our oils, and they are also organic compounds because they are built with oxygen, hydrogen, and carbon. Here's a picture of what a lipid looks like. It is a long chain of carbons linked together with a lot of hydrogens and a couple of oxygens. These are when you look at a nutrition label, these are your saturated or unsaturated fats. So when you look at a nutrition label, and I encourage you to go do that, you'll always notice the carbs, and then you'll notice the fats. And they might talk about being saturated and unsaturated. Those are what we call lipids. Protein. We all know that protein is very good for us. Each protein is made up of a carbon, hydrogen, oxygen, but now we're going to include some nitrogen in it and sometimes even sulfur. Proteins are made up of amino acids. So any type of protein, cheese, eggs, milk, meat, chicken, fish, chicken, fish, shrimp, they're all animals, so therefore they were living, and they are organic. Nuts are even considered organic because they are also a plant that is living. So, tomorrow, of course, we're going to have a card sort. So let's practice for that. Let's see the difference between organic and inorganic. Do you remember what it has to have to be considered organic? Eat at the Sponge Cafe, but the most important thing is the cha. So glucose. C6H12O6. Why is this considered organic? Because it has the C and the H, carbon and hydrogen. Chlorophyll, which is found in plants and gives them the color green. Caffeine, that you drink in your coffee, Red Bull, Monsters, tea, which by the way, tea has more caffeine than coffee, is organic. So now let's talk about inorganic things. These are things that are found in anything not living and do not have a carbon and hydrogen in their chemical formula. Salt, sodium chloride, carbon dioxide, what you breathe out and what plants take in, and water, H2O. Now, do not get this confused that do we have to have water to survive? Absolutely. But is water itself considered living? No. And it is not considered organic also because it does not have a carbon and a hydrogen. Well, that's it for this flip lesson. Pretty quick and easy. Here are some links. If you really aren't getting it or understanding, go to these two and see if you can, especially to the one above. And hopefully you can rewind and pause at any time. I'll see you tomorrow.